Hello students, welcome to the 8th tutorial class on artificial intelligence and fuzzy logic. And this class will be presented by myself, Dr. Sudip Mandal, Assistant Professor from Department of Electronics and Communication Engineering, Jalpaiguri Government Engineering College. So coming to the agenda of this class, basically in this class we shall study about the different learning techniques of artificial neural network. There are lots of learning techniques that exist in the literature. Among these, we mainly focus in this class on Hebbian learning and Perceptron learning, and we shall also discuss the implementation of these two learning techniques using example of AND gate. Okay, so let's proceed. So first of all, let's revise the basic concept of artificial neural network. As you already know, that artificial neural network or ANN is inspired from the biological neuron of human brain. Okay, and in case of ANN, we can see that it consists of basically two layer. One is called input layer, another is called output layer, and in between them it is possible there are also some hidden layer exist, but in case of complex problem. But if we consider only simple neuron, so we can omit the hidden layer. So basically this is the schematic of a simple neuron. You can see that x1, x2, x3 and up to xn are the inputs, and uh, these inputs are coming into an accumulator, where the uh, all the inputs are accumulated, and here you can see that bias is also applied here in accumulator. And obviously w1, w2, w3 up to wn are associated with each input, and it denotes the strength of each input. Okay, now after the summation, this net value is going through a activation function, and function is nothing but it gives our desired output. Okay, and it may be a sigmoid function, maybe identity function, maybe step function. Okay, so basically ANN can be used for, as you already know, in case of classification problem, pattern recognition problem, etc., etc. Okay, so to know the details of different learning techniques, we should remember the basic architecture of artificial neural network. Okay, so coming to the next topic, that is the learning in ANN. So what is learning? So learning means, as you already know, that to adapt the change in itself. Okay, and when we should adopt the change, when there is a change in the environment. Okay, so NN can change its internal structure when there is a change in the environment. Okay, so how can it change its internal structure? As you already know that in internal structure of NN there is weight and bias. Okay, so during the NN learning we need to change the weight and bias so that NN can adjust with the respective input and output pattern or behavior. Okay, so we need a method uh, so that the weight and bias can be modified, and that is nothing but the learning. Okay, so these methods are called as the learning rules, and rules are nothing but simply some kind of algorithms or some equation. Okay, so what do you want to say? That NN is very complex adaptive system. Okay, so based on the internal structure, respective output can be changed. Okay, so to modify its internal structure or to accommodate the input output pattern or behavior, we need to change the internal structure. That means we need to modify the weight and bias so that the NN model can fit perfectly with the input output pattern or input output dataset. Okay, so to change the weight and bias, that is known as the learning process. Okay, already we have discussed the different kind of learning process, like there is supervised learning, unsupervised learning, learning. Okay, so here basically we focus only two important learning techniques, that is called Hebbian learning and Perceptron learning. Basically, these are two very old learning techniques which are already which proposed in the around 1950 or 1960. But these two techniques are basically the foundation of the more complicated learning techniques or algorithms. So we need to understand these two techniques first, then we should go to the others learning techniques after that. Okay, so coming to the next next topic, that is the Hebbian learning rule. Hebbian network was first proposed by the Donald Hebb in 1949, and as per the Hebb's rules, the weight are found to increase proportionally to the product of input and output. Okay, so we have what we have during the training or during the learning process, we have the some kind of data set that consists of input and output pattern, or input and output behavior. So it is according to the Hebb's net that the weight should be modified. The modified value is proportional to the product of input and output. So you can write that W new, the updated value or updated weight, is W old, that means previous value of weight, plus x into y. If we consider x is the input and y is the output, so we can write that W new equal to W old plus x into y. So that is the Hebbian learning rule, how the weight will be adjusted. Okay, so it indicates that in case of Hebbian network, if two neurons are interconnected, then the weight associated with this neuron can be increased by change in the synaptic gap. Okay, so and we should try to understand the details of this learning technique with the example in the upcoming slide. But for now, we should remember that it can be applicable for the bipolar or binary data. Okay, so in case of real life data set like decimal number or floating value, so Hebb's network will not be implemented. Okay, so it should be remembered that Hebb's network is applicable for the bipolar or binary data. Okay, so bipolar, that means 0 1 minus 1, or binary means 0 and 1. Okay, and Hebbian learning rule can be is generally applied to the logic gates like AND, OR gate, NAND gate, etc., etc. And another important characteristic of the Hebbian learning rule, that it is kind of a feed forward unsupervised learning. So as you already know from the definition of the unsupervised learning technique, that in case of unsupervised learning, there is a teacher is present, which indicate that what is error, or which one is wrong, which one is right. Okay, but in case of unsupervised learning, there is no teacher. Okay, so here we can see that how Hebbian's rule will be implemented. Now these are the basically the training steps using algorithm. Okay, so initially what can be done during the training of artificial neural network if we use the Hebbian learning rule or Hebbian algorithm. So initially all the weights are set to be 0. Okay, so initial value of weight W equal to 0, and initial value of the all the weights will be initial value of the all the bias is also 0, and where n is the total number of input neurons. And after that, let calculate the output using the accumulator, that means y equal to b plus summation from I to n xi into wi. So by using this formula we can easily calculate y and or calculate output. And after that, we have seen that activation, there is some kind of activation function after the accumulator. But in case of Hebbian network, the activation function is generally considered as the identity function. That means y equal to t. Okay, that means output will be output of the activation function is the same. Okay, and next the weight will be adjusted. Weight and bias are also adjusted using the following formula, and you can see that wn, that means new weight, will be wo, that means old weight, plus x into y, where x is the input and y is the output. And moreover, the bias value will be also updated, and the bias value will be updated using this formula. There is slightly change in the two updation formula. One is for weight and bias. You can see that in case of bias, new bias value will be old bias plus y. Okay, so new weight equal to old weight plus x into y, and new bias equal to old bias plus y only. Okay, so you can see that this term basically x into y, that is the change in the weight, that means delta omega, delta weight, or delta w, x into y, and change in the bias, that is only delta b, that is only y. Okay, so this is the weight and bias adjustment formula, and this procedure will be continued. That means the steps from 2 to 4 will be repeated for each of the input and output vector. Okay, it is possible that in case of in any data set there is different kinds of possible input output pattern or input output combination. So for each of the cases, the w respective weight and bias will be gradually updated one by one. Okay, and it will be continued till the all the input and output vector is covered. Okay, now let's consider, or let's explain the Hebbian learning rule using some AND function or AND gate. Okay, so in case of two input AND gate, we already know x1 and x2. If there are two input, and if the bias is taken as one, so we know that in case of AND gate, when all the inputs are one, then we can only get the output value as one. Okay, and here we are considering the bipolar function, bipolar value. So obviously 0 is represented by the minus 1. Okay, don't use the term 0, but here we are considering the 0 as minus 1. So okay, so you can see that when one x1 is 1 and x2 is minus 1 and bias is 1, so obviously the output will be minus 1. Okay, the first simple condition for the logical AND operation is the all values should be 1. So you can see that when x1 equal to x1, x2 equal to 1, and b equal to 1, then output is 1. Okay, and else all the possible cases the output will be 0. That means you can see that target is minus 1, minus 1, minus 1. So we need to achieve this AND function using Hebbian rules. Let's start. So initially, as you already know, the weight should be initialized, and here the weight and bias, you can see that as we already want to define, as you want to design a two input AND gate, so obviously there should be some two input nodes. Okay, the x1 and x2. Okay, so x1 and x2, and obviously there should be two weight w1 and w2 associated with the two input node. So initially w1 and w2 are set to 0, and also the bias value b is set to 0. Okay, now let's consider the first vector. You can see the first vector is 1 1 1. Okay, so you can see that the first input vector is 1 1 1, and the target value is 1. Okay, now the new weight will be, as per the Hebbian's rule, is we already know w weight plus x into y. So w1 and the new value of w1 will be 0 plus 1 into 1, that is 1, and new value of w2 will be 0 plus 1 into 1, again y, and new value of the bias will be bo plus y, because that is 0 plus 1 1. So you can see that the updated value of weight and bias are 1 1 1. Okay, so now this is the uh, initial, this is the value of weights and bias that will be again used for the next updation. Okay, so now the above weights are the new weights. Okay, now when the second input is passed, then this weight, that means 1 1 1, that will become the initial weight and bias value. Okay, now let's consider the second input. You can see that second input is 1 minus 1 1, and target value is minus 1. Okay, now you can see that for input vector is x1 x2 v equal to 1 1 1, and target value is 1. So obviously the new weights and bias will be like this. So you can see that w1 n equal to 0 plus 1 into 1. Sorry. Okay, sorry. Yeah. Okay. Sorry. Yes, yes. Okay, so the the second part, the second input 1 minus 1 1. So my mistake. Yes, this slide I should coordinate with the slide. So the second input combination is 1 minus 1 1, and the target is minus 1. So you can see that the change will be x1 into y, that is -1, and change in w2 will be x2 into y, that is 1, and delta b equal to y, that is -1. So new value of w1 will be 1 minus 1, that is 0. New value of w2, that is 1 plus 1, that is 2. And new value of the bias will be b plus delta b, that is 1 minus 1, that is 0. Okay, so the updated weight will be -1 2 0. So similarly, like this way, the input, depending on the input output pattern, the respective weight and bias will be gradually updated, and this process will continue till we cover the all input output vector. Okay, so you can see that this table basically show the final Hebb net for the AND function. You can see that but this is the initial value of the weight. Okay, so weight change for the first inputs, you can see that weight change is 1 1 1, and we get the updated value of w1 w2, and bias is 1 1 1, and after that we get updated value of w1 w2, and b is 0 2 0, and for the next input pattern we get 1 1 minus 1, and finally we get the final value of the weight and bias as 2 2 minus 2. Okay, so by using this combination, by using this matrix, and function can be achievable. So if we implement here, you can see that this one is the NN structure that has been obtained up by using Hebbian's rule. You can see that x1 x2 are the two input node, and this one is the basically bias node whose value is always fixed to 1, but there is some kind of weight associated with the bias value, and whose bias value bias of the sorry weight of the bias is -2, and you can see that here new weight is 2 2. So here, so we can associate that that is by 2 2. Okay, so if we implement this, so we can easily get AND function. So that is the Hebb algorithm. Okay, so by Hebb learning rule, the main concept is that w new equal to w o plus x into y, and bn equal to bo plus y. Okay, so that's two things should be remembered. Okay, and another thing that is it is unsupervised learning techniques. Okay, so why do we call unsupervised techniques? Because here there is no teacher is present. Okay, so we just consider using some kind of formula. We don't compare with the actual output or with the target output. Just we are using the some numerical equation, and calculate the respective output. Okay, so here no teacher is present who told you that this is wrong, this is right. Okay, we don't compare with the original calculated value of output or the target value of the output. That's why this is Hebb's learning algorithm is called unsupervised learning technique. Okay, and it should be remembered it is applicable for bipolar or binary input output combination. Okay, so this is the Hebbian learning algorithm. Now coming to the perceptron learning algorithm. Okay, in case of perceptron learning algorithm, we are normally prepared the perceptron network, where we are a perceptron network basically nothing but the single layer feed forward neural network. It is possible that in case of perceptron network, multiple output is possible, and it is also possible that there is some kind of hidden layer associated with the perceptron. So the perceptron network may consist of an input layer, a hidden layer, or output layer. But for simplicity, right now, or to understand the perceptron learning algorithm more easily, we don't consider the hidden layer in this class. Okay. Now, coming to the next point. Here, another thing, in case of also perceptron, here also the input and output is bipolar in nature. In It is possible, that means it can take -1, 1, or 0 also, and wait. Yes. Okay. And another thing that in case of perceptual network or perceptual learning algorithm, we consider the activation function as the step function. Okay, binary step function. Okay, that is that function will be expressed later. Remember that in case of Hebbian learning algorithm, the activation function is the identity function. That means calculated value is the same as the output, same as the output value. Okay. So the in case of perceptual learning algorithm, we are considering the bipolar, um, bipolar value, and the step function as the activation function, and it is called as the supervised learning algorithm. It is also, it is an example of supervised learning algorithm, because here we will see that there is some kind of teacher will told if the output is right or wrong. Okay. And if the output is wrong, then obviously the weight updation or bias updation will be taken. Now continue here. Here we are considering the output of the perceptron as y equal to f small y, where small y is the calculated value of the accumulator, and f is the function, that means that denote the activation function basically. And here we are considering a binary step function, and it is here we defined here like this way, that fy value will be 1 if y greater than equal to threshold, and greater than threshold, sorry, and it will be 0 if the value of y calculated value lie between minus threshold and plus threshold, and if it is less than minus threshold, so obviously the value will be minus 1. So this kind of activation function has been considered for the perceptron learning rule. Okay. And weight updation take place between the hidden layer and output layer, or the input layer or hidden layer. But here we do, again I'm telling that here we don't consider the hidden layer for the simplicity or for the better understanding. And however, here we calculate the error in between actually output and the desired output. Okay. And you can see that here the weight updation and bias updation formula has been expressed in the following way. You can see that as per the perceptual learning for rule, the new weight value will be w old plus alpha into t into x. Here you can see that mm, uh, one new parameter or new parameter has been introduced here, one that is called the alpha is called the learning rate. Okay. And this is basically the constant value throughout the algorithm or throughout the iteration. So what is the function of the alpha? Basically, as per learning rate, that means how fast a model can learn. It is, if the value of alpha is very large, then means it can the value of the uh, w value of the weight can change abruptly. Okay. And if the value of alpha is very small, that means the weight updation will be take very slowly. So we are considering the based on the value of alpha, the speed of the learning will be varied. Okay. So by default value of alpha is 1. Okay. And we will consider value of alpha is 1. But the thing is that depending on the value of alpha, the learning process will be faster or slower. Another thing and value of introducing alpha is that it is possible to jump out from the local optima during the iteration. It is possible that one value or one weight has been stuck into a local optima. That means the value does not able to change from that area. So by introducing this value, it is possible that value can be jump out from that local optima. So these two things should be remembered, and these two things is the important characteristic of alpha. Okay. However, so in case of perceptron learning rule, again I'm telling that these two rules should be remembered. Wn equal to wo plus alpha into t into x, where t is the target value or target output and x is the input. And bias value will be b old plus alpha into t. Okay. And alpha is the learning rate. Fine. So coming to the some important characteristics that should be remembered, that here in case of perceptual learning rule, that weight updation don't take will take uh, for a certain condition. Okay. So if the output match with the target output, that means suppose using uh, the output of the accumulator, output of the accumulator Oh, sorry. The calculated output. If the calculated output matches with the target value, then no weight updation take place. Okay. But if the output, calculated output, does not match with the target, then weight updation take place as per the earlier formulas. Okay. And remember here, weight and bias, both are all initially set to 0 or 1. And the value of weight and bias will be gradually updated till an optimal solution is found. And it should be remembered that after the perceptual learning process, the perceptual learning will converge to an optimal weight vector that consists of weight and bias value also, and so that we can get the correct output for the all input training pattern. Okay. And this process will be continued for a finite number of steps until you get the desired accuracy. Okay. And remember that perceptual rule can be used for the both binary and bipolar, and perceptual learning is supervised learning because we know the uh, which output is wrong and which output is true. Okay. And if the calculated output does not match with the target original output or original or the target output, then weight updation will take place. Okay. So that's why you are that's why you can say that a teacher is present which indicate that which output is wrong, which input is true. Okay. So that's why we are calling perceptual learning as the supervised learning technique, whereas Hebbian learning is unsupervised learning technique. Okay, so now coming to the training steps using the perceptual learning algorithm. So first is let there be n training input vector xn and tn, where x is the input and tn is the target value. Okay, now initially the weight and bias, it can take any value like 1 or 0. So set them basically 0 for the easy calculation, and let the alpha value of the alpha is 1. And for the input node, the activation function is identity function, so we don't need to consider this. So next stage is that to calculate the output of the network. So here you can see that output of the network is output of the accumulator is y equal to b plus b summation x into w for all input vector from 1 to n. So by using this formula, we can calculate the output. Now we apply that activation function. So we already know that if y greater than threshold, it will be 1, and similarly for the other two condition, it can take either 0 or -1. So based on the value of the calculated y, we can get the value of activation function as 1 or 0 or -1. Okay. Now based on the output, now let's compare the desired target output t. So we need to compare the value calculated output y with the target output t. So if these two values are the same, we don't need to update the weight and bias. But if they are different, that means if y not equal to t, then obviously weight updation will be take place. Okay, so here the formula, as you already discussed, the wn will be w0 or wo plus alpha into t into x, and whereas the bias value, new bias value, will be bo plus alpha into t. Okay, where alpha is the learning rate, t is the target value, x is the input value. Okay, and wo is the old weight value, bo is the old bias value. And if y equal to 2, we don't need to update that. That means wn equal to wo and bn equal to bo. Okay. And we need to you need to understand that this process will be continued until there is no weight change. Okay, so we need to cover the all number of input output patterns, and after that, when there is no change in the weight, so we should stop at that point. Okay, and we can say that the optimal condition has been achieved. Okay, so that is the learning technique for the perceptron algorithm. Now again, let's elaborate this perceptual learning algorithm using AND function similar to earlier one. So as you already know that x1, x2, and we are considering the bias value. We have the bias value don't is not showing. So when x1 equal to 1, x2 equal to 1, and b equal to 1, so obviously target will be 1, and else all for all the cases the output will be 0. Here 0 is represented by the minus 1. Okay. So now let's start the, or let's implement the perceptron learning algorithm for this purpose. So initial stage, you can see that for the first input vector x1, x2, and b, sorry, x1, x2 is 1 and target value is 1. Okay. So here you can say that in w1, w2, and wb are 0 initial value, and x1, x2 and bias is 1 and t equal to 1. So net output will be y equal to b plus x1 into w1 plus x2 into w2. So that will be 0 plus 1 into 0 plus 1 into 0, that is 0. So here just coming to the activation function. So when y equal to 0, you can say that the output of the activation function is 0. So we get the output value, calculated output as 0. But let's check that if the output y equal to target t, you can see that output 0 but target is 1. So obviously the condition is not satisfied, so weight updation will be take place as per the earlier equation, and you can see that the weight value of the new weight w1 will be 0 plus 1 into 1 into 1, that is 1, and value of the new weight is 0 plus 1 into 1 into 1, that is 1 also, and value of the new bias is 0 plus 1 into 1, that is 1. Okay. So here you can say that delta w equal to alpha into t into x, and delta b, that means change delta b equal to alpha into t, that means change in weight is alpha into t into x, and change in bias, that is alpha into t. So after this calculation, you can see that new weights are 111. Okay. Now this will be forward to the next step. Okay. So after the first input vector, the new weight we get 111. Fine. Okay. So coming to the next step 2. So now that we can consider the second input combination where x1 equal to 1, x2 equal to minus 1, and b equal to 1. And if this condition has been given, so obviously target will be minus 1, because this is the end function. For apart from the all the condition 111, all value will be 0. Okay. 0 is represent here minus 1. So you can see that, but here w1 equal to 1, w2 equal to 2, and wb equal to, sorry, w2 will be also 1. So this one is 1. So w2 is 1 and w equal to 1. So by using this formula, we get the net output b into 1 into 1 plus 1 into minus 1, that is 1. Okay. So if you use this, so first condition, if y greater than 0, the output is 1. So therefore again target is minus 1, does not match with the actual output 1. Okay. So weight updation again take place. So by using the same formula, we get the new w1 as 0, and new weight as 2, and new bias as 0. Okay. So the new weights are given as w1 equal to 0, w2 equal to 2, and wb equal to 0. Okay. So like this way it will be continued. Okay. So you can see that for the all for this four input output combination, we get the ultimate value of weight and bias are 1, 1, and minus 1. Okay. So this is here another thing, it should remember that or you should consider another thing that is called as the epoch. What is epoch? Okay. So epoch is basically nothing but iterative procedure. That means here uh, all four input output combination has been covered, and we get the ultimate value 1, 1, minus 1. But it is possible that for this input for this weight combination 1, 1, and minus 1, that all the input output combination has not been obtained or satisfied. That means accuracy has not been satisfied. Then again what will happen? Then again iteration again, then that means again using this weight, again the iteration process will be continued from the step one, from this input output combination 111, it will be continued. Okay. So that is the epoch. Okay. So epoch 1, epoch 2, epoch 3, possible that many number of epoch is needed to get the or to get the or to achieve the desirable accuracy. Okay, so the epochs are the cycle of the input pattern fed to the system until there is no weight change required and iteration stops. Okay, so here you can see that the definition of the epochs are the cycle of the input pattern. Okay, so yeah, at first epoch all the inputs are covered. At the second epoch, again it starts from 111, like this way it will be continued until no weight updation is required. Okay, and the iteration will be stopped. You can see that the final value of the weight is 1 1 minus 1. You can see that 1 1 minus 1. Okay, and you can see that here 1 1 1 is minus 1 ultimate value, and there is no required to continue as the epoch 2. So we can stop here, but you can in real life problem you can see that we need to use like epoch number 10, 15, 100, like this way to get the desirable output. Okay, so coming to the conclusion, so in this tutorial class, we have discussed two learning algorithm, Hebbian's learning algorithm and Perceptron learning algorithm. So in case of Hebbian learning algorithm, the change in the weight vector is proportional to the multiplication of input and output. And Hebbian rule have been hugely applicable for pattern association or pattern recognition or categorization problem. On the other hand, in case of Perceptron learning rule, it is both applicable for the single output and multiple output, and it can be applicable for the classification and prediction problem. And the goal of the perceptron network is to classify the input pattern into the particular member classes. Okay, and the weights are adjusted to match the actual output with the target value. And again, I'm telling that Hebbian and perceptron learning rule are um, example of unsupervised and supervised technique respectively. Hebbian is the unsupervised technique, while the perceptual learning technique is the supervised technique. Okay, so that's all. If you, these are the some references. So if you have any problem, please post them. Thank you.